Welcome back, everybody. Welcome back to the channel. So, 2.9 releases out. That's pretty exciting. And what we're going to be talking about today is not only the 2.9 release, but also how I go about creating releases with my programming language. So first, before we get started, let's just first look at the actual release. So let's see what happened. So I'm going to go here to the docs and let's just look to see what's new in 2.9. So, in really quick, guys, I had a hot mess this morning. I tried to release 2.9, and long story short, I messed up a bunch of stuff. Now, it has nothing to do with this language. Basically, what ended up happening, long story short, I ended up having to delete the version 2.805 from the releases because I just messed up a bunch of crap. So, I apologize for that. To be honest, you're not missing much because this version isn't that good anyway. But if anybody is looking to test this version, you could always just shoot me an email at devcode.channel, and I can always shoot you over a zip file that contains all the information. Looking at 2.9, this was released, well, it was prepared yesterday, but it was really released on September 2nd. Today, and basically the bug fixes, pretty big stuff, guys. Several seg faults. Function pointers are no longer object types compatible. That was just a simple bug in my compiler. A huge amount of compiler code generation bugs have been fixed. This is one of the major things. I was actually fixing a crap ton of bugs yesterday before I actually prepared the release, and so it's made the language even more stable. I also fixed several code optimizer bugs. So one thing I want you guys to realize is as you're testing the programming language, the code optimizer is a pretty good optimizer, but there's a huge danger in optimizing code because you're literally shifting around and moving source code. So there's a potential that your source code could not work. So I will say this for anybody who's testing. If you're testing the programming language and you've optimized the source code with the option -O, please make sure that if your program is not running as expected and you think that you've tried everything, just try to remove that option. And I know it's the fastest way of running the programming language. There may be a bug that you have found in the actual language, so keep that in mind. After that, we have several bugs related to lock statements. So when it comes to mutexes and stuff, tons of bugs there that were fixed. I also fixed a massive bug with the code obfuscation system. Apparently, it was crashing the system, which was great. I fixed that yesterday. So that's good. And now let's look at the quality of life improvements. Obviously, we know about the garbage collector being very fast, so the garbage collector is much improved in this version since the last version. I also improved the task scheduling API written in Sharp for more faster and efficient scheduling. That's going to be really nice and helpful for you guys. I also increased the stability of the multi-threading platform, which is really cool, as well as several memory leaks in the actual runtime system. Now, I know I said yesterday, or what was it, the previous video, that I was looking to increase the class limit size from 200,000 to 8 million. I actually was able to increase it to 16 million, which is double what I said. And basically how I did this, guys, was very simple. It wasn't very difficult. The way that I got the limit for the actual maximum classes was based on the, opcodes. So obviously every opcode has its own format here, and each format has its limit. So what I did was I picked the smallest opcode that operated on a class object, and I just looked to see what was the maximum width. So basically what I ended up doing was there's a new class function, and I basically just made it a doubly sized instruction. Now, I hate doing this. I really don't like doing this because it does make the programming language a lot larger in terms of executable size, but I'd rather have a lot more classes than 200,000. So I basically just moved this from a D class instruction to a double-sized instruction. I also did that for, I had another one as well, new class array. I say new class array. That was the second one that was also interacting with the class object. And I made this a double-sized instruction as well. And that's pretty much it. So that was literally the only things that I needed to do. And then, of course, in my compiler, I went into the backend and the compiler and updated the class limit, which is now 16.7 million, whatever. So this is the actual limit. And now this is the limit that I actually should have had in the beginning because if we go to the actual runtime system, symbols, objects, they basically have a limit of 24 bytes for the total class address, which turns out 24 bytes has a maximum value of 16 million. So that's what I should have had in the beginning anyway. So yeah, that's done. And after that, the executable file has been updated, guys, to version 5 because I did have to switch some instructions around. The class instructions weren't the only things I switched around. I did a lot more than that. New addition. So I finally added 32-bit operating system support for Linux. This should have been updated. I should have updated this. But it's basically for Linux only. I tried for hours yesterday to get support for 32-bit on Windows, and it just wasn't working. It's not that my language doesn't support it, it's that I can't get the project to build on C line. So it's a build issue, and it would take a lot of work for me to like get it to work. So I only put that in for Linux this time. Hope you guys understand. And hopefully it'll be in maybe next version. I'll have to see. I added the is keyword. You guys already know that. The wait notify system. The new Sharp native bridge to interface with C++. The previous version did not have that. Also, as far as known issues, the GIT is not supported. The profile is not supported. We've already talked about that. And dictionaries are not fully supported in the language. I still haven't gotten around to doing dictionaries. So next update, that will definitely be in there. But yeah, so that's one thing. Also, one last thing before we start getting into how I actually build these releases is basically whenever you install a release, I'm now adding the runtime version and the compiler version to the actual release version. This way, once you install the release, you can verify basically that these values are correct, and that way you know you have the latest release version. This is just an extra way of validation. And if you guys also noticed, I have this backwards compatibility support version. What this is going to be, I've had this for, I think, a couple of versions now, yeah. It's supposed to basically represent me testing the language in backwards compatibility mode, meaning that if you ran, version 2.805, the source code that you wrote in there can also run in this version. Well, whenever it says NA, that means that you have to recompile the source code because there's been a change most likely to the executable file. So then, the support and backwards compatibility isn't valid anymore. So keep that in mind. I'm working on making that a lot more stable. The language is just rapidly evolving, so it's kind of difficult to do that. But now let's actually look to see how I actually go about releasing the programming language. So now that the programming language is released, I did a lot of things different this time. So one thing that I will say also too, and sorry I'm bouncing around, but also too, if you guys look here, there's a examples folder now. This examples folder is going to be in the release package. So if I go up to the version 0.2.9 release, it is going to be in that release package.zip. So you can check out that. Basically what this is I've written a file for you guys that will help you kind of get started with the programming language. So I know there's a lot of people new to the YouTube channel as well as the programming language, and you may not have watched all of my videos. So I created this examples folder to kind of help you get started. Not only does it have like a C++ example in there, I also have like simple to more complicated things. So I have like atomics for multi-threading. I also have, a simple factorial file. I have stuff dealing with my threading system to, create multiple threads. And there's tons of comments here, guys. So if you have any questions, it most likely will answer it in there. I also have a very extensive deep dive into my task scheduling API that I created a while ago, as well as I even created a neural network for you guys. So just a simple example program to kind of show how you create a neural network in the actual programming language. So there's definitely tons of stuff to look at. So I definitely look out for that. Now, let's actually get into how I made the release. So what I did was I usually do this on Linux because it's just a lot easier. So I have this deploy.sharp file. Now I'm actually going to copy this, and basically what I did was or actually no, it's in here. So I created this deployment folder, and this deployment folder basically represents any source code in there that needs to be used for deploying the programming language. So if I close all of these, and if I go here to deploy.sharp, This is going to be a Sharp file that's responsible for kind of helping speed up the process when it comes to deployment. So whenever I create a release, I create this release folder. Now, for whatever reason, it doesn't have the information in there, so I'm going to be bouncing back and forth between two screens. But basically, I guess I just didn't commit it by accident. Every time when I create a release, I need to put in there a bin folder. And in there, I have the binaries for everything. So I have, 32-bit Linux, the Sharp compiler and the Sharp runtime system. I then create this folder and, put for 64, Linux and Windows, the Sharp compiler and the runtime system. Once I do that, then I add in a examples folder, and these examples are basically going to be used for, the programming language to help people get started. And then finally, I add the support library as well to the actual lib directory. And then I add in, a couple other files in here as well. So I add in the changes file, and we've kind of already gone over this stuff before, but basically, if I, it's kind of frustrating. Okay, I wish I actually committed this stuff, but basically the changes file is just what we were just looking at. It's a change list of all the things that I've done to the programming language. I also have the getting started file. And to be honest, guys, this stuff doesn't really get updated that much. Literally, I update the changes file in real time as I'm like upgrading the programming language. So I just copy and paste that from the docs folder. So I literally just delete whatever's in here, copy and paste that. The getting started file doesn't really change that much, so I rarely ever have to do anything in here. The Linux install bash also doesn't really change. I mean, the only thing I have to change in here is the support version number, but that's it. I mean, there's really nothing I end up changing in here. So I basically try to figure out if the system is a 32-bit or 64, and I do that by, calling this command here, uname, and I check to see if, the processor architecture is x86 64. That means it is a 64-bit PC. So then I, cd into the bin 64 Linux folder, otherwise bin 32 Linux folder. And then everything else is just, I just installed the language. So I copy everything from the bin and put it in the /bin in the system folder. So that means that this does have to be executed as root in order for me to do that successfully. To install the standard library, I just cd into the support library directory. I make a directory of include.sharp, copy that everything.sharp in there and paste it into the include. And then I also copy recursively everything / I'll copy all folders into the user include sharp directory as well. Then I cd out of that support directory, and then I try to compile the test .sharp, and then I run it, and that's it. I mean, so it's pretty straightforward. I also have this Notepad++ syntax file. We've already gone over how to actually do that, but basically this is a way for me to add syntax highlighting. And then finally, I have this test .sharp file, which basically allows me to basically make sure that the language works and everything. So why do I have this deployment folder then? So the deployment folder, as I've mentioned, is for deploying, but it's not just for that. So it's also used for unit testing. So when it comes to actually running my language, I've always had to do so much manual crap that I've gotten tired of doing so much manual stuff. So I've automated some of the release process. Basically what this sharp file does, so I create a file called examples. So I'm inside of the deployment folder, and I access the examples folder and I create a file for that. And then I call list on that folder. So basically what that's going to do is return me every single file inside of this folder. Once I do that, I need to filter out the stuff that I don't want. So what I do is I filter out the C++ code because I just don't want to do that. I want to do simple things like atomic, list stuff, class stuff. So I check to see if it is an examples file, meaning that if it's in the examples directory and not in a subsequent directory nested deeper into the examples folder. So I do that by creating a new file. I pass in the test file, which is going to be, a file that's in this actual directory, and I get the parent file. And what that's going to do is that's going to get the parent folder that owns that file. And then I convert that value to a string, and I say, does that end with examples /? And if so, then that means that the file that's in here is basically inside of this examples folder and not in a nested folder. So Once I have done that, then I basically also check to see if it's a .sharp file. Obviously, if I have other stuff in there, I don't want to compile it. And I also don't run console stuff. The purpose of this is to automate testing this programming language. So whenever I do a release, I'm going to basically try to compile all this. So let's actually see an example of this running in real time. So if I go to, so I'm going to clear this here, CLEAR. All right, so if I clear this, I'm going to compile the actual source code for the deployment just to make sure that I have the latest source code because I keep changing it. And then you're going to start to see it running a unit test on everything. So if I clear this again, and then I actually run the source code, this is going to say sharp unit test runner running unit test 1 of 12. And basically what it did is it's running 12 unit tests, which are basically filtering the specific files that I want to test in the examples folder. And it's going to compile each file a specific way and then run it in a specific way. So I do a couple different compiles. So while that's running, let's kind of look at this because it is going to take a while. So I do a simple test where I basically compile the programming language with no specific parameters. I just say compile whatever file that I pass in here, and I output it as a test. This is the output executable. And then I say sharp test to basically execute it. I do an optimized test because, as I've mentioned before, the optimizer can sometimes be problematic. So I, compile it with the optimize flag and then run it. Then finally, I do a release test. So this is going to be an example of a release executable. So I compile it with the optimization flag, the release flag, which strips all debugging info. And then I also obfuscate it as well because the code obfuscation system is pretty complicated and you want to make sure that all that stuff works. And then finally I run it. Now, I know some of you are thinking, well, how do I know that any of these tests are working, right? Basically, the basic concept is I ended up having to make a change to my compiler, and it's very simple. So you guys can do this as well. So if I go up to the lib directory, go to the grammar, backend, and the where is this? Oh, it's in the main. Okay. So if we go to the main directory or the main file, at the very bottom, I'm now returning as I exit this function. So in the bootstrap, which represents the main function for the compiler, I'm now returning a result from the compile actual function. And what I'm doing is I'm returning whether or not it's failed, basically. So if failed is equal to 0 means that no files failed. And just to be sure, we have 0 errors. So I check the option for aggressive errors, and I pick which one that I'm going to be picking. But basically, the premise is if no files failed and we have 0 errors, return 0. Otherwise, return 1 from the process. And the sys command is going to get a result based on whatever, process that I'm executing inside of this sys command. And if that is equal to a value and it's not equal to 0, then I'm going to return 1, which is then going to register as the unit test failing, basically. So when I run all these 3 unit tests, I'm going to check to see if all these values are equal to 0. And as I'm executing each, process, I'm going to make sure that, it's not equal to 1. Now, what about the virtual machine? Well, the virtual machine is pretty simple because I already have technology in there to basically return the value from the main function. Basically, when I return out of here, I just get the function from the actual program. So if I go to the main directory, so if I go to main.cpp, I'm literally just pulling that value from the VM's exit value. And if I go to thread, or actually, no, it's here. So it's in the virtual machine. So whenever I run the interpreter thread start, at the very end, I exit the thread and I check to see if the thread is equal to main ID. I call shutdown. And then when I call shutdown, I do this check to check to see if we need to destroy the system. And this is just to protect against multiple threads trying to shut the system down. Once I call destroy, I assign the exit value based on the thread self's exit value. And the thread self's exit value is derived from accessing the last integer on the first integer on the actual stack. So basically, since I know that I'm always going to return an integer from the start of a thread, I basically am always going to have a value here. And I do it based on the locals because if you remember, the user stack starts after all of the thread locals have been, allocated on the stack. So just keep that in mind. But yeah, that's pretty much how I do it. So that basically guarantees that these unit tests are going to work. And I literally just run all of these. And once that kind of gets finished, is it done yet? Yeah, so once it gets done, it's going to ask me basically to confirm releasing of the language. And if I say no, it's just going to keep asking me basically. But I can just, hit Control C and be done. But yeah, so let's go back to the actual file. So if we go back here, if the unit test is false, meaning that all these values weren't equal to 0, then I say unit test failed. Otherwise, I say unit test passed. And then, I create a divider line. And then I just run that, basically forever until I run out of unit tests. After that, after all the unit tests have passed, I ask for confirmation. I read a character from the console. I put a new line, and then I basically check to see if it's equal to Y. And if so, then I basically create the release. So the way that I create the release is I call the zip command, and I basically just zip everything inside of the releases directory into a file called release.package. And that is going to be located. So if I go back up here, that's going to be this release.package here. It's going to create this little zip file. And then once that zip file is done, then I'm going to update the branch by, adding everything in the branch, committing with a commit stating the release version, which is whatever I put up here. And then I push all the code on the current branch. Now this is where it gets into a little bit more manual work. I'm working on automating this process as well. But basically what I do is I go up to, GitHub, and I go to, or I click releases. So if I go back here, I click releases, I click draft new release, which is going to take me to this type of screen. You put in your information, I paste in the same crap every time because I have the same stuff. It's just the runtime environment and the compiler. And then I just paste in the release package, and I select pre-release and upload release, and that's it. Now, obviously, you do want to merge into master before you actually create a release. So make sure you do that. But that's pretty much it. So this is kind of how I create a release. Let me know if you guys have any questions. Hopefully I explained it well enough. So once you install the Sharp programming language, and by the way, I've also added those instructions to the README file. So it's at the very bottom on how to actually get started with the programming language. And there's a typo. But yeah, basically this tells you how to install the programming language. This information is also inside of the release package folder as well. So you can always check that out as well. But once you kind of get everything ready, then you can literally just, go into Notepad, make sure you include the language. So you want to go to user define language, and then you want to click import, and then you want to basically just find the folder that contains the actual Notepad++. So in the actual release, you're going to have a Notepad++ Sharp. So you want to find that XML and include that in the Notepad. Once you do that, then you should be good to go, and you can literally just go up here to language, click Sharp, and you'll have syntax highlighting. That's going to be it for today, guys. If you have any questions, as always, put them in the comment section below or send me an email. And let me know in the comment section below how things go with the release, if the language is better, if it's more stable, or if there's issues. And of course, you can always just send an error or a bug report. And I typically have a quick turnaround time when it comes to fixing bugs. Usually whenever I find a bug, I fix it pretty fast. And yeah, so hope you guys enjoyed the video. As usual, if you're new to the channel, definitely consider subscribing. And until next time, I'll see you guys later.